Lesson 11A, question number 10. Graph the following nonlinear system of equations and identify the two solutions. And remember that a system of equations, to a linear system, all the equations would be linear. If even one function isn't linear, then the whole system is considered not linear. So in this case, I have this first equation. The function is x squared, which tells me that it's a quadratic, or polynomial to a degree 2, which you would have seen as we were graphing some trend lines in the last section. Okay, so this one is called quadratic. The next one is what type of function is y equals x plus 3. This because I have x to the first power, or it's just 1x, this tells me that it's linear. Okay, the next thing is using your graph below to identify the two solutions. So the first thing I need to do is graph this equation here. To graph that, I first need the vertex. To find the vertex, the first thing I want to do is find the x coordinate of the vertex. To find that, the equation is negative b divided by 2a. All right, so now I need to look over at this equation here, and b is, it goes a, b, c in standard form, so b is 6, so that is negative b, or negative 6, divided by 2 times a, and a is the coefficient in front of the x. Since there's nothing here, that means it's a 1. Okay, so we have negative 6 divided by 2 times 1. 2 times 1 is 2, so negative 6 divided by 2 equals negative 3. And that's the x-coordinate of our vertex. To find the y-coordinate of the vertex, we just substitute every time we see x as negative 3 into the equation. So I'm going to copy and paste this over here, and every time I see x, I'm going to put in parentheses, because every time I substitute, I want to make sure that I get everything in where that x is. And one thing that helps with this one is that it doesn't look like I'm subtracting 3, but that I'm, in this case, 6 times negative 3. And this 2 came out of the exponent, so I need to do Shift 6, and I'm going to copy and paste that into Excel because it'll make it really fast. And we have those resources, so might as well. Okay, Control V, pasted it in there. The only thing is Excel doesn't understand that between the 6 and the negative 3 that I need to multiply. So you have to tell it to do that operation. Okay, press Enter, and that was very fast. We get negative 2. So equals negative 2, and the y-coordinate of our vertex is negative 2. So to graph in Maple, it wants that vertex first, and we'll go negative 3, negative 2. 1, 2, 3, negative 3, and then down 1, 2 here. Oh, that's not quite there. Let's move it just a little bit. As close as we can. That looks pretty good. Okay, the next thing we want to do is find the y-intercept. To do that, that means where x is 0. So substituting 0 in here, 0 squared is 0, 6 times 0 is 0. So I'm really just looking at c, or this last number here, which is 7. So that tells me that this parabola crosses this y-axis at positive 7. 5, 6, 7. Again, let's try and get as close as we can because we're looking for solutions in this one. That looks good. Okay, now the next one is to graph this line. It's already in slope-intercept form for us, so that's very nice. And the intercept is this positive 3. So I'm going to tell it we're going to do a line now. And that tells me that it's crossing right here at 1, 2, 3. And I'm going to try and get there as close as possible. That looked pretty good. Pretty close. I think that's pretty good. Okay, and so when we were graphing before, I wasn't as exact. I am on this one because I'm going to use the graph to try and find where these two intercept, and it's helpful if they're really precise. The next part is the slope is positive 1. To make that into a fraction, because slope is defined as rise over run, I can take this whole number and just divide it by 1. So that tells me that I rise 1 and I run 1. So from this y-intercept, this point on our line, I'm going to rise 1 and run 1. I could continue doing this because all of these points will be on the line if I rise another 1 and run 1, rise 1, run 1. These are all points on that line. I could even go backwards and go down 1 and backwards 1. That gives me, or if I were to say that slope, it would be -1 divided by -1, which is still the same thing as +1, because -1 divided by -1 is +1. So it just gives me another way of going backwards on my slope, this direction. And that's convenient because I just saw that it went through those two corners. Let's just stick with our normal. Let's go rise 1 and run 1 for our next, and try and be really precise. If I'm off just a little bit, it won't go through all those corners. Oh, it looks like it went very well. It looks like it's going through here and here because I was pretty precise. If you are struggling with that, one way to ensure that your graph looks really nice is to make sure that you're going down 1 over 1. And if I'm off over here somewhere, then go back and kind of readjust these guys so that it definitely goes through each of those corners. All right, so it's asking for list the solution xy with the smallest x value. So I want to go as far left as possible because that's the smallest. To the right is bigger, so the very left is -4. Yep, -4, -1. So x value first, -4, and then down -1. So this is -4. And the y value is -1. And it crosses through twice because we have a parabola here and it's a nonlinear system, which is really fun. The next one, the largest x values, so this is -1 and up 2. So this is -1, +2. And I think that was the last question there. All right, so we can verify that. It's validating to have all of the green check marks. Good luck on question number 10.